A smooth pulley has a mass of 6 kilograms and 1 kilogram hanging from either side by means of a light inextensible string. The system is released from rest, and after 1 second, the 6 kilogram mass is suddenly held. Find the common acceleration of the two masses. Okay, so what it is if you ever see this, like these like sort of diagonal lines, that means a fixed surface, can't be moved, okay? So what I'm doing is I'm attaching my pulley to this fixed thing. It's like hanging a pulley from a ceiling or something like that. It just isn't gonna move, okay? So that's my drawing there. Now, what did I say about these pulleys the other day? Are they spinning or what's happening? It's sliding, yeah? Like that, sliding, okay? And it's frictionless, that's our assumption. Assumption, no friction, and the other assumption is the string doesn't stretch or whatever, yeah. All right. Now, we have 6 kilogram here. Okay, that's your 6, and this is your 1. Okay, what's our prediction when we let it go? 1 goes up with acceleration A, and 6 goes down with acceleration. You cool with that? Now, what's holding it in place or slow? Sorry, what's causing the 1 kilogram to go up? Yeah, but 6 kilograms isn't connected to it. What's actually connected to it? So therefore, it's actually tension that's driving that upwards. What's actually slowing the 6 kilograms down? Tension. Because it's the only thing that's connected to the 6 kilogram particle. Okay, what's causing it to go downwards? It's weight or gravity, 6g. The other one, 1g. Now, you pick one of them, you either pick the 6 kilogram or the 1 kilogram. Let's go with the 6 kilogram. Okay, force, you're always using force equals MA. You cool with that? Now, your force is going which direction, up or down, your net force? It's going down because it's falling. That means you're putting your weight before your tension. Have we got that? See the direction? Weight minus tension is downwards, okay? So it's going to be 6A equals what's weight? G, and then take away T, because T is going in the opposite direction. Now next to the 1 kilogram one, what about the 1 kilogram one? What do you think? Force equals, it's going up, isn't it? So what's that? What's causing it to go upwards? So it's T minus, so it's in the other, the letters in the other way around, aren't they? So what's 1A, is that okay? And then T minus G. Now what you see here is we have ourselves a nice little simultaneous equation system. And this tends to happen a lot. You sort of just line them up and add downwards. What happens if we add downwards? 7A, yeah, equals 5G. Exactly. Because the T's will cancel when you add downwards, yeah? And then what we get in A as 5/7G. Sub in 9.8 for me and just give me an answer. I think it's like 7 or something like that. Or less. It is 7. All right. You all right with that? So, would you all agree that what's happening is the common speeds? Now, after 1 second, so would you agree that this one's moving upwards? So this tension, that string goes upwards, and this guy goes upwards. And the 6G, what happens to that string? Yeah, it gets a bit, it does, the overall string doesn't get longer, but the 6G falls a little bit, okay? And all of a sudden it's held. Bam, we hold it. Is that right? It can't go any further. We're looking for its velocity just before we hold it. So we're going to use U VAS. What's our U value? System is started from 0. Our V value? That's what we're after. We're after the V value. We're after the common speeds. However fast the 6 kilogram mass is moving, the 1 kilogram mass is moving the same speed. Gotcha? Okay, so we're after V. Our acceleration, which is 7. Our S value, our T value. Okay. Choices. It's a pretty easy choice. Thank you. U plus AT. And then this will say V equals 0 plus 7 times 1. And then the answer is ms minus 1. Now, what happens when a 6 kilogram particle is stopped? What happens to the tension? Tension instantly turns to 0, which means we have no tension, which means our acceleration system is now gone. The acceleration we had is based after tension existing, right? So that's gone, okay? And what happens next is the 6 kilogram particle for all intents and purposes is gone. The system has stopped for you, okay? And the tension is gone. Now what's the deal with the 1 kilogram mass at that point in time? What's its story? But it was moving at 7 meters per second. I didn't stop it though. The tension stopped. So look, it's on its way up. The way it goes up a little bit. So it's on its way up. But the problem is it's going at 7, but it no longer has acceleration in the upward direction. What's the only acceleration acting on it? Gravity acting down. So we're going to UVAS this again. It's starting off U is when it reaches its greatest height. What's your velocity at the top of your greatest height? 0. You can't go any further. Your A value, minus 9 points. Your S value is what we're after. Our T value, we do not know. Options. We're after the S value. What one should you use? Yes, somebody's on form today. V squared equals U squared plus 2AS. And what do we get here, guys? V squared is U squared. 2AS, so minus 19.6S, because A is minus 9.8, so minus 19.6x. Move it out your side. 49 divided by 19.6. Well, 5 over 2. Okay. 2.5 meters it rises.